Is it good? Channel 1? No channel 1? Good. Okay. So as some of you may know, Camlistore is a way to store, sync, share, model, back up some content. We talked about it extensively with Brad last year at FOSDEM, so I invite you to check out the video if you have time afterwards. And I'm still going to do a quick recap of what it is, so you know what we're talking about. The main goals of Camlistore are that you should be able to deploy it anywhere because you want to stay in control of your data and to own it. So you can do it on Google Cloudy things and Amazon, but also on your server at home or wherever you want. The second point is that you should be able to dump anything, all your data in it, without worrying what kind of file it is, how it has to be organized. You just dump it and you don't worry, you forget about it. And then we want to have a good and sound schema to model your data and some good indexing and search so that while it's in Camlistore, it's easy for you to find your data and work with it. And as it is a server, of course, we have a bunch of clients to interact with it, a web UI, some command line tools, user interface, some importers, clients, also like some other servers that are standalone and can interact with it. The main components, the core layers of Camlistore are these like 3 components. We have like what we call a blob server. We have a schema to model the data, and then a good search system on top of all that. I'm first going to explain what a blob server, as you probably expect, is like a storage in which there are some like small chunk of data, like no more than 16 megabytes, and you don't care about metadata. It's just your data, your raw data, like this. And then on the Go side, a blob storage, a blob server just implements. You just need to implement those methods or interfaces: fetch, receive, stat, enumerate, remove, etc. And then on top of that, you have, of course, an HTTP API. So you can address all your content by the SHA-1 hash of a blob. And the advantages of working at this blob level and to address your blob like that is that it makes it very easy to sync. You don't have to worry about any merging logic. You do that at a higher level. And it's easy, of course, to check for corruption, integrity, and you get deduping quite easily. And I should mention that as long as you're able to implement those interfaces, you can do it on any backend. So you can have a blob server running on memory, on your local disk, and all the cloudy things as well. And that's what we've done. And then we have this kind of schema to model your data. So all the blobs, they are immutable, but your content it's constantly moving, right? It's constantly mutating, and you want to be able to reference your content at like his latest version. So what we use is this specific blob, which we use as an anchor, which is called a permanode. And we model the mutations by issuing some claims which target this permanode. And at the end of the day, you take all the claims which target this permanode, and you have the state of your data at a given point in time. And all those permanent claims, they are GPG signed, and that's all we model ownership. Everything that you have GPG signed is yours on a blob server. And no one else, of course, can decrypt it and access it. And then we have a search system on top of that, which is basically first to index everything with a sorted key value. So it's a Go interface where you have a get, set, and find as usual, which gives you an iterator. And same story, as long as you can implement these methods on any backend, MySQL, SQLite, whatever, it gives you an indexer that you can plug for free in Camlistore, and that works with our search, which is a system of high-level queries and describe requests, which also, of course, has an HTTP API that you can work with. So that's it for the recap time. And now I'm going to talk about what we've done in the past year on Camlistore. So the first thing is that we improved a lot the importers we had. We can import like Picasa, Twitter, Foursquare, Flickr data, and now they're much better. I'm going to mention it afterwards. We have a publisher app standalone server. We have a ton of web UI improvements, a lot of more CLI tools, a thing called Blobpack that I'm going to explain afterwards. We use Docker a lot more, of course. We have HTTP2, of course, and we have this new shiny tool to deploy directly Camlistore on Google Compute Engine. And, of course, a ton of bug fixes, optimizations about images, a lot of things. So the importers, we had them for a while, but now they're like, they have a cleaner schema, and they're more stable, and they can run automatically and periodically, so you don't have to worry about starting them. So all your data from Picasa, whatever, can be constantly imported in your Camry Store server. And this data is now much better rendered in our web UI as well. We have a ton of stuff about the web UI that I'm not going to enumerate because that's not really the point of this presentation. I can quickly show you a few snapshots. I don't even know how you click on Mac OS X. That's it. So first one should be, this is the basic index page that you have. You have this little pudgy menu on the left with which you can do a lot of things. Here is how you do a search on our search bar on the top by tag, for example. This is all the images that were tag.go. This is the container view. We have a new attributes editor in JavaScript, so you can change everything on your perma node directly from the web UI. This is the blob view that allows you to see everything about your content. This is like classic web UI stuff. You can select all your thing, and then you can mass tag them or delete them or whatever. And an image view, of course. And this is the status of your server, so they can see all the things going on, and you can even restart it as well. But this is more like a debug page. This is good. We don't care anymore about the images. OK. We have also a bunch of tools that I'm not going to enumerate, but just to show them, they are here. And so we have this new thing called Blobpack that is mainly done by Brad, of course. And it's basically a new blob server implementation that you put on top of any other blob server that we have, and which gives you a more efficient logical layer, because you get much faster reads and less seeking, because all the blobs that should be logically together because they belong to the same file. They're part of the same file. They're rearranged together in a larger 16 megabyte blobs. It's basically a zip file. So then you can stream them all at once when you want to retrieve a file or whatever. So you stream that much faster than if you had to seek for all your blobs on your storage. And the other part is like a smaller, loose blob server of small blobs, the ones that you would access frequently and you don't want to have to fetch inside the zip file. And there's an index that you can rebuild, etc. So as I mentioned, we're using Docker a lot more. That allows us to, run all our tests inside of Docker, so you don't have to have a MySQL, Postgres, etc. on your computer. You can do it in Docker. We have integration tests. We are building Android inside it, the Android application we have, our release images, and importantly, our Camry stored image that we use to deploy on Google Compute Engine with CoreOS. HTTP2, of course, we have it, as you probably know. And I'm going to attempt to do a small demo of this launcher, if the network gods are with me, and if I know how to type on this keyboard. So we have this shiny form here, which tells you that you should create a new Google new Google Cloud project, and you can see the pricing, etc. And you enter, so your previously created. Is this typing correctly? Yeah.
This isn't your laptop, you know.
Sorry?
This isn't your laptop.
Yeah, so I'm trying to type like a few keys. Yeah, we're gonna enter any password like Pony. This is the password we're gonna use afterwards. You can choose a zone where you're gonna deploy your stuff. I want the B one because I'm cheating. And you can choose your instance as well, and you can try and deploy now. It will ask, of course, with the usual oath dance, the permissions that you need, right? And it's not going to work because this is your account, right? Of course. That's it. So Brad doesn't have a Camry MPL project, of course. So this doesn't work because it's not my Google account. So there's not much more we can show at this point, unless you want to create one real quick. But
I've tried it and it works. It's pretty cool.
then you get the web UI that I showed you, basically. And you get a success page with all the explanation about how to tweak your Camry Store instance if you want to, but it's already ready. Like you want to maybe issue new, because we're creating the TLS certificates for you, of course. So maybe you don't trust us. So we explain you how to remove them and add new ones. same thing, you can add an SSH key to access your instance from anywhere. You can do it from the Google Cloud interface, but you can also do it from anywhere. This kind of configuration stuff. And yeah, that's about it.
All right. Let me see who's next. What are you talking about again? Or just introduce yourself.
Yeah, hi, I'm Alexander Neumann, and I will be talking about a backup program I'm writing in my spare time since about a year. And let me see if this works better.
Let me just stick this in your back pocket here.
Okay. Okay, something's wrong here. Okay. Yeah.
All right, so now we have Alexander Neumann, who's going to talk about Restic, his backup system, and he's also an expert at getting Linux to project onto a
Okay, the question you're all asking yourselves is now why another backup program. So I'm gonna just, this is my use case. I have a shared directory in my home dir, and that's 16 gigabytes, 140K files, and 40K directories. That's quite huge, and I would like to do backups. It must be easy because otherwise I'm tempted to skip it, and I'm rather lazy, I must say. It should be fast. There are several limitations I'm willing to accept. For example, CPU, hard disk bandwidth, or the bandwidth to the storage location. That's okay for me, but latency and inefficiency is not acceptable. And the other thing is that most people don't want backup, they want restore. And it's really important for me. So this is a citation from the admin Zen on backups. There is quite some truth in there. So I would like to verify my backups, and that should be automatic for a test that tests if restore is possible, and that should be regularly tested. And it shouldn't need my intervention, and it should run automatically and just you report back if a restore is possible or not, because when it's not possible, then I have to fix it. I'd like to be it secure, so that integrity is protected, confidentiality is protected. So I'm trusting my local machine, but not necessarily the backup location where I'm pushing my files to, because there might be an administrator that would like to see what pictures I take or something like that. So I would like to encrypt and sign all data. I would like to use a proper key derivation function. I chose scrypt in this case to derive AES keys from a password. And I would like to not have any overly complex data structures, because in the disaster case, when I need to restore something and there is a bug in a program, I would like to be able to get my files out of there without the original program. So it should be as simple as possible. And it should be efficient. In this case, there is some features in there that I implemented with Restic. It should, every snapshot should be a full backup. I would like to not have to distinguish between incremental and full backups. I would like to only save the relevant data that has been changed since the last backup. I don't want to store duplicate data, but I would like to maybe include additional redundant data afterwards. And all backups should be removed efficiently. That's something, for example, that BAP hasn't implemented up to date. They're recommending changing the backup location regularly so old things time out, and that's not acceptable for me. For the storage or the repository, at the moment implemented is local file system and remote. And remote in this case means SFTP. You don't need a shell on the other end, but you have to have an SFTP access over there. And the repository in my design is add only, except when you purge old backups. So this is no problem when you have, for example, several servers pushing into the same repository at the same time. You don't get the optimal deduplication, but that's not necessary. But nothing breaks if that happens. The threat model, because I'm working as a penetration tester in my daytime job, it's very important for me. The local machine is trusted, but the repository location probably is not. So I would like to detect manipulation and even something like faulty RAM or faulty hard disk on the remote side or something like that, and that on several layers. What I cannot protect against is an administrator on the other end deleting my files. That's something I cannot protect against, but I would like to be notified if some files are missing. The features are implemented in Go, obviously. It's already very fast. We will see that later. It does deduplication with content-defined chunking, very similar to what Cambly Store does. I've looked at that, but I chose another algorithm that I think is better suited for this task. It uses Rabin fingerprints, and I had to read a paper by Rabin, which is typed on a typewriter, and there's a scanned version and a PDF. It was very hard to read, but an excellent paper. You should read it. Then I'm using AES in counter mode. I'm using HMAC with SHA-2 and script. And I have some unit tests. I have a test suite at the moment implemented in Bash because I would like to have a second language besides Go for that. And but this might change in another time. And I've set up a continuous integration server with Werka. So every push to the GitHub repo is automatically built and the test suite is running. And at the moment, it's licensed under the BSD 2 clause license, so it's free software. The teaser, this is my use case from the beginning of the talk, 16 gigabytes, 170K file, 140K files, 40K directories, and so on. This is, the example was running on my laptop here. It's a rather old ThinkPad with not so much RAM, but at least an i5 processor with IES hardware acceleration. And creating a backup repository is really easy. You just say restic -r and then where you put where the file should be put. And say init, and it asks you for the password. The initial backup is this one. It scans for 16 seconds, and it takes 9 minutes and 1 second to write everything to the repository location, and it does deduplication and signing and encryption, everything in there. For a second backup, you can give some kind of a blueprint of the first one. You can specify the SHA-2 commit ID for the snapshot. At the last line, you can see 5911, and you can give that as a template for the second run, and you can see that it scans for 16 seconds, and the second backup just takes just about 2 minutes. And that's not really optimized at the moment. It's just,
These speed numbers are workers. What are these?
The speed numbers, first percentage, then the amount of data that has to be backed up. And there's the first one is the current speed, and then we can see that in a minute when I'm showing it to you. At the moment, for the repository, I'm trying to use content-addressable storage. So everything is referenced by the SHA-2 hash of its plaintext content. That's very similar again to Cambly Store. For small files, I'm just saving them. For big files larger than half a meg, I'm splitting them with CDC and save the chunks. For directories and everything regarding metadata, I'm just using JSON documents which are compressed by zlib and afterwards encrypted. So these data structures are really easy. This is the rough repository structure. On the left hand, all the IDs are SHA-2 hashes, and they are just shortened for the first 6 bytes or something like that. So you can see there's a snapshot. That's a JSON document that's referencing a tree. The ID is the plaintext hash, the SID is the storage hash after encryption, and the tree contains a subtree and a test file there, and some references what content in which order is there. Status quo is it works. It should not be used for real data yet, because I'm not really sure that it does what it says on the outside. So it needs more testing. I would like to present it to you. Please have a look at it. The repository structure might change. I'm not really sure that this is the right structure, but there is already a version field included. So when I'm doing a new revision, then it's version 2 of the repository or something like that. Implemented actually are local storage and SFTP. So, but there is much room. Further development is, I think it can go much faster. I'm thinking about a factor of 1.5, maybe 2, maybe even more. I would like to add fuse support, more accessing backups via HTTP. So for example, starting a RESTIC server process somewhere and having an HTTP server serve you the files that are in the repository. I'd like to include more repository types, for example, FTP, HTTP, S3, and so on. And I would like to, at least for Linux, support extended attributes like ACL and so on, because these kind of stuff seem to be missing from all the other backup programs, and that shouldn't be so hard to include in the JSON file in the metadata or something like that. And I would like to include a CLI shell so you can type in multiple commands. So quick demo about that. Can you read that? It's OK? OK. So I'm just going to create a repository that's within it. It's asked for the password. Oh. So that's it. And afterwards, I can back up, for example, a subdirectory for the sake of demonstration. So this is 1.5 gigs, something like that. And you can see it's pretty fast, because this is the storage is /temp is a temp of S for me. So this is just reading and encrypting, and writing is basically a no-op. So yeah, and then you can see in 10 seconds it should finish. And I have many ideas where this can be improved to go even faster. And now it says the snapshot has been saved under this ID, and I can give him this ID as a template, and then it just says that, oh, everything is fine, and you have some commands like, for example, you can list the snapshots and so on, and can restore them. OK, that's it. Thank you. Do we have time for questions?
Yeah, maybe we'll take one question.
OK. Any questions?
What do you have in mind as an optimization?
For example, the rolling checksum code for chunking, it has to look at every byte. That's what I was talking about with Brad. And at the moment, it works and is semi-optimized. But I think with more knowledge how Go allocates things, and you can look at that and make it even faster. Because at the moment, I'm getting, on my hardware, I'm getting 130 megabyte per second throughput, something like that, in one thread. And I wrote a small C implementation, and that was without optimization at a factor of 2 faster. So you can even, with CGO or something like that, you could link it in, and that should improve a lot. Yeah.
Do you trust the file system timestamps to know that a file needs a new backup, or do you actually verify it?
At the moment, for a backup without referencing a backup from the time before, then everything is scanned and dedubbed and so on. And for the second backup, I'm trusting the timestamps at the moment. But there is a feature request that you can, for example, -- check data or something like that, so that the data is read again, so don't have to trust the timestamps.
That would make sense.
Yeah.
Isn't it dangerous to truncate the mid batches?
Yeah, this just for
That's just display.
just for display. And on the other hand, when there is a conflict, then the hash doesn't work. So when you, for example, when you have 2 snapshots, yeah, yeah.
1024 Thanks. I'm just going to stick this in your pocket.
Happened. All right.
All right. Please welcome Alexander Fiore, who's going to talk about Go as the building block for the internet, or a diameter protocol.
Yeah. Hello, my name is Alexander Fiore, and I work for this company called Sandvine.com. And at Sandvine, we do broadband equipment. So equipment for mobile networks, for fixed networks, for Wi-Fi networks. So we're basically on the other side of most people here in this room. Like I believe most people here are in the business of running stuff in the data centers, servers, services, and I'm on the other side. I'm running like stuff for where people come from to the network. So all of your phones, when you're connected to your mobile network and you're accessing the internet, so you're passing through a lot of different equipments, and this is what we do in my company. So I'll talk a little bit about this implementation of the diameter protocol, which is very popular in this environment. And I'll tell you where it is used and how this is used, and how I did it in Go as part of my learning of the language. So there is a spec for this. 2 years ago, I decided to learn Go after I read a blog post from iron.io or something. And I was like, there's something in this language. Decided to learn the language. And as part of my learning of the language, I decided like 4 months later to write an implementation of this protocol, because it's something that we use almost every day at the company. So I just opened the RFC, started writing the code, and got it working. My goal was to have a message rate in this protocol similar to the stuff that I was seeing from vendors, like 5 to 10,000 messages per second, the really good ones like 10,000 to 20,000 messages per second. So I decided to write an implementation of this protocol. So where's this protocol really used? This is part of the 3GPP specs. So everyone that is running access networks, mostly the carriers, they have equipment in their network that speaks diameter. This is an evolution of the radius protocol, right? Used for accounting, used for a bunch of other stuff. So these equipment, like we have, for example, the subscription profile repository, that's in the carrier where your profile is. So basically, what is your plan? What is the speed that you get on your phone? And what is your quota? That all lives in there. All these equipment, they talk to each other via diameter, in real time mostly. The second one, the PCRF, is the one that gets that information. When you get a new PDP context, you unlock your phone. The antennas are sending messages to RNC, down to the S gateway, down to the P gateway, and those are generating diameter to some other equipment that are down the line, which are these ones. So basically, the SPR will send a message via diameter to the PCRF, and the PCRF will install a rule in the PCEF, which is the thing that we produce. We build this little baby here. So it's really, this is a PCEF. This runs inline in the network. So basically, all of your traffic goes through this equipment. And this is what is actually doing billing for you, what is actually applying your profile, and doing all that. And this is all over diameter. The PCEF is that equipment that I just showed you. And there is also the OCS, which is doing online charging. So as you browse the internet, it's consuming from your quota. And the way this works is like, as you browse the internet, the PCEF that knows your profile is sending diameter messages to the OCS to take bytes from your credits, right? To take from your accounting. The reason this whole thing works, this is part of the 3GPP spec, and this is why some carriers today can do like, all of your WhatsApp traffic is free, is not charged, because the PCEF can recognize your traffic and say that this is WhatsApp, and we will charge you in the OCS in a specific rating group, which is free of charge. So this is why you have like, in South America, it's really popular, some plans that you can buy from the carrier, access for only Facebook and email. Some people don't care about anything else, and it's pretty cheap. So these equipments are doing these things. And it's all over diameter. So I decided to write an implementation in Go as part of my learning. So this was my first attempt to write the diameter protocol. And I got it really fast. I was expecting like in the 10,000 messages per second. My first attempt, this is like 2 years ago, and I got like 25,000 messages per second. So this started to get more interesting. I did this in my basement. I have 2 boxes in there, 2 i5s, just sending messages from one to the other. These messages, they look like this. I have a capture here. So this is the first message that is sent from one equipment to the other to acknowledge the capabilities. So for example, they have an origin host, an origin realm, and all that. So these messages, they have AVP similar to radius, key value pairs, with all the information. So this was a benchmark of my two Go programs sending messages to each other, right? So that was my first attempt. And when I was reading the spec, I was like, well, as I was learning Go, how do I read like data structure, or how do I read binary data into my data structure? So I just decided to use binary read, binary write. And then a little after that, I learned that I was actually using reflection. That turned out to be really slow. So when I got rid of that, I got some much better rates, which are really unexpected for the types of equipment that I was working for. Those guys, even the more expensive ones, they're like in the range of 40,000 messages per second. It was like, wow, my little toy Go program here is already much faster than that. And basically, I was just getting rid of reflection in there and using what I should be using. That it took me a while to learn all this stuff. You know, just reading from the big engines, writing directly, not using binary read and write to read and write stuff into my data structures. So after all this, I learned even more. If you can look at the dates when I ran this. So 2013 and then 2014, and then by the end of the year, I was like already writing Go every single day. This became like my main language to Go. And then I've got some more cleanups. I added a sync.pool and some other stuff, and I got some really good rates now. So this is still running in the servers in my basement. And now I can get almost 1 million messages per second with this little toy implementation of the spec. So what I wanted to talk about today is like, you know, in 5 minutes, just to give you a heads up. If you're still learning Go, it's better to read all the documentation before you start writing code, right? Because sometimes, as you can see, like I started with something really simple that worked for what I needed with like 25,000 messages per second. But you know, a year later, as I learned more about the language and how to do things properly, like it got much better. So I added like some lock-free dictionary lookups. These diameter messages, you have like dictionaries, which are usually XML files, where a protocol, a sub-protocol of the diameter is implemented. So one of the things that is implemented in diameter is like charging applications. So you have an entire dictionary with a command and what are the AVPs that go in those commands. So in order to run diameter, you have to actually have a dictionary, parse that dictionary. And then as you read a diameter message from the wire, you have to do some dictionary lookups to parse that message, right? And those dictionaries are actually dynamic. You can create your own, and you can roll out your own application in diameter. So it took me a while to learn all this, but the Go tools actually helped me a lot. So as I was running this stuff, I've been always running benchmarks and a bunch of tests. You know, from the beginning, I wrote all the tests I could, I wrote all the benchmarks I could, and I was always measuring what is fast, what is not about what I'm doing. And then I just learned, like, you know, reading messages is much slower than writing messages. So these are the AVPs. You can see here that, you know, these ones, the decoders of the AVPs are really, really fast. But to read an entire message and do the dictionary lookups and all that stuff is much slower, right? And is also much slower than writing a message to the wire. But you know, because I've used these tools from the beginning, I could actually see the difference. As I was changing parts of my internal APIs, I could see the differences. So when I started, this was like 20,000 nanoseconds per operation, and then went down to 7. And the reflection of this in the overall messaging in between my toy programs got much better. So again, write tests, write benchmarks, keep an eye on them all the time, as much as you can. This is not a really, really popular protocol, so you don't see this every day if you're not in this business of like in the access networks. And what's next here is like, part of the spec is like SCTP. We don't have this in Go yet, and I don't know if we're gonna have this in Go. There's actually a fork of the entire standard library that adds SCTP to the net package, but I decided to not use that. And also the state machines of the diameter. In the spec, they define some state machines from when the equipments connect to each other, what messages they exchange. I just do that in the code right now. I don't have this in my package. And this is slightly becoming the stuff that we put in the equipment. So this was it. If you have any questions, just try to make it really fast.
I have a question. How do you currently store dictionaries?
Is an XML file that at the beginning of when you run the program the first time, I load them up all in memory, and I index them all. Yeah, I use a few maps. Because sometimes you want to look up for an AVP by name, sometimes you want to look up for an AVP by code. Exactly. I parse them all, create all the indexes, and as I read the messages, so the API for running the client and the server is based on the net HTTP. So you do your diameter, handle func, and then listen and serve, very similar. So it's really easy to use. All right, that's it. Thank you.
Thank you. Thank you. Oh, thank you.
No, I was actually testing with the real ones.
All right. No time to waste.
Oh.
All right.
Yeah, we can run those. It's just a quick power, but you can run it anyway. It's much easier.
All right. Now I'm going to introduce Francesca Boy to talk about Go enums, JSON encoding.
Cool. So, does this work? Oh. Not anymore. Yeah, can help me there. Cannot really see it. So, I'm going to be talking about how to encode and decode JSON in general. But actually, how many of you have used Go enums? Okay. So the context is there's no such thing. Okay. There's no Go enums. But instead, what we have is we have integer types, and basically you define a type which is an integer, some kind of integer, or bytes, or whatever. And basically you end up having a series of constants, each one for each value that you want to have. And I did this, and I was like, OK, that's cool. Now I want to encode something that has a slice of weekdays, in this case. And I try to print it, and I get this. And I'm pretty sad at this point. It's like, really? Like, this is not really useful for me. But then I read the specs, and I have a longer talk about this. But basically, you have to use JSON marshaller. It's a really cool interface that allows you to specify the way a given type is marshaled into JSON. So I just added this, which just basically checks in the map which value of the day I have and what's the corresponding string. And I run it, and now it works. And now I'm happy, and then I realize that I have to write that code by myself for every single type, and I'm not happy anymore. So what's the problem? The problem is that this code is very boring. So boring that a computer should do it, not you. So what I did was exactly that. So the code generation that I wrote is basically, I don't know how many of you have seen this command called stringer? OK, so basically, I just copy-pasted stringer and modified it. And I changed the way I didn't really like, well, it's a pretty complex problem. I wanted to have something really simple. Even though it was not that fast, I didn't really care about that. And what I did was I parse the code. I do the extraction. So I extract what are the values that I want to generate and so on. Then I actually generate the code. And at the end, I format it, which turns out to be super easy because GoFunt is a library. So the parsing, I'm not going to get into details, but basically you get a bunch of files, and you extract information from it, and you end up parsing things. Now, the thing is that just parsing is not enough, because you also you might be using things from other packages, so you actually need to use Go types that will allow you to know exactly what type is any identifier. So I end up having a map that basically I can say what type is this thing, and I just get a type, which is exactly what I wanted. Then actually extracting the values turns out to be a little bit difficult, because in this example, the type pill, you have 3 values: aspirin, paracetamol, and acetaminophen. So aspirin, what type is it? Well, it's obvious, it's pill. Paracetamol, what type is this? Well, you have to remember what was the type that you were defining before, because if there's no type, there's a type from before. It's like, OK, cool. And now the last one is acetaminophen equals paracetamol. OK, what is paracetamol? Now you have to end up remembering what's the type of this given identifier. So that's when Go types actually helps. By the way, if you don't know that in the United States, if you need paracetamol, you have to ask for acetaminophen. I learned that one day. And then I actually generate the code. And to generate the code, basically all the previous process, what it's doing is filling that struct on top. I have a command that I will use to say, hey, don't wipe this file, don't modify this file. This has been generated with this command. Just run it again. And I then use text templates. So text templates, I guess that most of you have used HTML templates. So text templates is exactly the same thing, but without any escaping. And it turns out to be perfect for what I wanted to do. My code basically looks like this. It's package name. I don't still, oh, package name is missing. No, it's still there in the structs. And then for every single type in the types and values map, I just go and generate a Marshall JSON, and then for every type, and then the case has for every single value for the type, I generate that little line, which is if you have that constant, then generate exactly the same thing with the double quotes on the sides, which turns out to be a string now. And that's it. So it generates this code for the weekdays, which is not especially beautiful, but I don't care, and that's the funny thing. Yeah, I don't even need to read it. I don't need to maintain it. So a little demo. So in here I have my pill.go, which is what I showed before, pill.go. So I have a main that prints the 3 pills. If I do go build and I run it, you will see it prints 001. Now if I do JSON enums dash type equals pill, and I go build, and I run it again, now it prints my value. That's it. It generated the code, and now I just have it. And now the last step is that since this is so easy, I can integrate with Go generate. And to integrate with Go generate, I just need to add that comment there. That's it. That's everything I need to do. There's one little thing. You see there's a blank line between that comment and pill. That's because otherwise that could be appearing on the documentation, which is pretty ugly. So I have to be careful with that. And the last thing is I actually saw someone doing this, which I'm not sure if it's a very good idea, but basically, since JSON enums might not be there, and if you do Go generate, I still want the command to run. So just do go get on my tool, and then I run the tool, which works. I don't know if it's a good idea or not.
You could import with the underbar.
I was thinking about Go.
Make it a dependence, right? Dependence.
Yeah. Yeah, anyway. Not sure if it's a very good idea. But anyway, to show it again. So if I do Go generate, it will just do exactly the same thing. So it pre-generated that pill.json. So cool, and it works. So it's on GitHub, and you can use it. You can see the way it's done, and you can use it for Kit adapted. And if you find any bugs, just don't let me know. Thank you.
So is the next speaker here Stefos? That you? Cool. Great. So we're now going to hear from Stefos. Is that how you pronounce your name?
Sort of, yeah.
Sorry. I'm going to keep a very provocative sounding talk. So go fix the Windows command line.
And you chunk it up. Yeah, IPGA.
Oh yeah.
Something changed in the middle. Yes. Most two blocks, I think. Yeah. Depending if there's an overlap. So that's good. It's very nice.
Is there still power available? Because I think that might be. Is there a power?
Yeah, under that blue hatch there.
Yes, they changed. They add like one row here.
Yeah, not really, because
Oh yeah, yeah.
Not just for that, but you know,
Which colors do you want?
blue and pink. Boy and a girl. They're gonna be really happy because I showed her on the website and she was crazy about it. Yeah.
You didn't get yours. What color do you want? Blue, pink, purple.
or do you have maybe two?
Well, he has 2 kids, that's why I gave him 2.
Okay. After the one.
Yeah, it's a serious problem.
It's unfair to take just one home.
Thank you.
Yep, you're welcome.
Yeah, you don't want to forget about it. Yeah. Yeah, I'm so jealous.
Yeah, my favorite.
Hey.
Language that only she's not so interested by.
Yeah, my girlfriend loves him as well. It's very strange. So you were saying about
First thing I can do is just play one megabyte. Second,
equal.
when you add a byte in front, everything shifts and you get complete input blocks. That's bad. So that's the reason why I'm doing content different chunking. And so
That's why you split differently from
exactly. And no, can we still do the same thing with a different output? So I have calculated fingerprint for every 264 bytes every file. So
a bit like
This is working way too plug and play.
okay, so that's large not size and different.
because I was just one of my main So I was looking at the artist thing. If you can do it chunking.
Yeah, but it's pretty good because you can delete stuff and only this block is different. All right. And
So, I'm Seb. I work at a company building embedded systems that we distribute all over Belgium to do energy monitoring. The company is called FitPlay. You might have heard of it. And one of the things we needed to do is get SSH connections to our products in the field. So we do this basically by setting up a reverse tunnel. So we ask the gateways in the field to please set up a connection to a server so that I can log into you. Well, so that's basically the goal of the whole thing. There are a few problems with this. We need to support OpenSSH certificates. I want to do this. Wait. We need to do APA calls to our backend, and it needs to be portable. So I want different users to use it. So the main goal was to do Linux because there's already a Windows GUI application that does this, and I don't want any dependencies so that you can put the program to set up the SSH connection on a memory stick, plug it in, and just use it. So the plan, after some consideration, Go seems like an ideal tool. It has multi-platform support. It solves the dependency problem by just statically compiling everything. It has the crypto SSH library, which is awesome, and the net HTTP library, which is also very awesome. And it's hip and cool, so I didn't know what to use, and this is the thing that's most popular, like companies use, so why not? Oh, why is this? Hey, I lost the slide. I know. So I will just show you what was on this. So it worked. It worked on the implementation is pretty simple. It's just using the SSH library, and it even ran from the first time on Windows. If my VM wants to show it, but it looks like this. So not good. Linux does not support anti-escape sequences, something I was not expecting. So since my goal was to make it run on every platform, I needed to fix this somehow. So, and in Go, this was actually pretty easy to do. Yes. So how are we going to fix this? Basically, we have to capture the anti-escape sequences and call corresponding Windows API calls so that we can do things with the terminal. So basically build a terminal emulator. That's
Hey, are you
yeah.
wearing the mic? Your volume might be a bit low.
Oh, sorry. I'm not sure. it okay now? Test. Just don't move it. Okay. So yeah, after some looking around, I found this thing, ANSI-Com. So it's good to know that other people have the same problems as me, which does exactly what I need, but it's a kind of a demon. So it runs in the background and it listens for connections. And it's a big dependency, so you have to ask users to install it. And it's the first idea I had was maybe it's a library, I can link to it and I can just use it. But it's basically a big C file with every logic in there. It's like 2,000 lines of code of all states and stuff. So not really nice. So let's rebuild it. So what I did is just made a Go fork of a C program and started everything from scratch. Actually copy pasting the code and just adapting it to Go code. So yeah. Well, I guess I wasn't actually planning to do a demo here. I just heard you can have like these plushies and I wanted one. So this is the not working code. I want this on my monitor. There you go. So you can see the non-working version here. And basically, I'm going to make the boop, boop, boop. This is damn it. There you go. So now I've changed it to just run. Hello, Windows, come on. Oh, I'm still in SSH session actually. That's why it's acting up so weird. So I have to do like, there we go. So now I'm back here and I run it again. And let's see, it should. There. So just to show that it works. If it works, there we go. So it works and I can even do like top and it even does like every strange ASCII escape sequence to clear things. And so how did I do this? Pretty easily. So one of the goals I also had, I wanted this to work on Windows, but I didn't want all the crazy ANSI escape sequence detection inside programs that also had to run on Linux. So I wanted to keep the program I was going to use small, and if people on Windows wanted to use it, so be it. So, oh, cut. This trackpad is very terrible. So, this is basically what GoANSI-Com is. It's just one function, and it does convert. And this is the function that it calls. This is the thing that happens on Linux. So the beauty of Go interfaces, you can just pass it an IO writer and return an IO writer. And everything, all the magic happens in between. And this is what happens on Windows. So basically, you can see I've used an IO reader. Yeah, some things I learned using this process. So if you go all the way down, I've also learned that you can have, it's not open. Kernel. So these are syscalls. I'm not sure if anybody is familiar with them. But one problem I encountered was that Go has no union type. So a lot of these, actually one of these functions, there are other kernel calls in Windows that use union types, and that was something I had some trouble figuring out. How do I get this to work? So there used to be a lot of C code inside of this file, and I managed to get rid of it all. So I'm pretty proud of that. And actually, when you think about it, an interface type is also a union type. And that is basically what is here. So there's a char info, which is a special character that can be both a Unicode character and a normal 8-bit character. So, and I use this in this function, which is screen buffer info, which is a very needed function because that is actually the thing that clears screens. When you do stop, you see this strange thingy going up and down. That uses a union. So what I did is just made the union an interface, and it works, which is pretty surprising. So I think I thought it was a good idea to share this with the world. You can use interfaces as union types. If you look for it on the internet, you don't really find a lot of information about this. So yeah.
Can you explain that a bit better?
Yeah. I don't know if you're familiar with what a union type is.
Yeah.
So basically an interface is you just tell Go, I don't know what this type is. It can be multiple things. And that's also basically what a union is. And there's a lot of talking on the internet about Go doesn't have union types. There's even a big repository where they try to do the thing that unions do.
But a union also shares the space in memory.
Yeah.
Is this happening here too?
Well, it seems to be, and there's I don't know how it works, but it seems to work. Maybe the project that won the Google award thingy with the project that you can show what is inside your struct can actually solve this. And probably it will work because basically what you pass to the Windows API calls is a pointer to the struct. So if that works, then it's probably just the same in memory as. So it will probably reserve the biggest thing that's going to be in here, which is the Unicode character, which is 16 bits. So it works.
All right, you're out of time.
Yeah. Any questions or?
No time for questions.
Oh, no time for
Sorry.
questions.
For the record, yeah, if you have an empty interface value, it will actually store a pointer to the thing in there instead of the thing itself. Yeah, like the interface value is represented by a type descriptor that says what the underlying concrete type is, and also a pointer to the value. So there'll always be indirection there. It doesn't actually inline it. It used to store if there was a value that was smaller than a pointer, like a input 2 or something, it would actually store it inline, but it doesn't do that anymore.
That actually might be the explanation.
Oh, I see.
I guess we need that Windows.
Trying to immediately fix to you.
Try to minimize the amount of
Yeah, but the
force on
type
it.
name should be there, so that's confusing.
Wonderful.
I think that
You are very
Yeah, that looks great. Thank you.
I would have just turned it on.
Which color do you want? The third color.
Oh, doesn't matter.
Blue?
Oh no, that's not right at all. What is this? A Linux machine? Yeah. If I were mirroring, I would be
Arrangement?
arrangement.
So yeah, just keep it real short.
Yeah. Oh yeah. Yeah. I'm like 5 minutes at total. I mean.
Yeah.
And then this is all wrong because of something? Because the resolution is wrong. System preferences, displays, scaled. Can the projector take it?
Can. Do it.
Confirm. All right, everyone, I'm going to be really quick because
because it's late, and or something. All right, there we go. There's a slide. Okay, Android. Go on Android. So I gave a talk recently at Gotham Go at a conference in New York, and it was recorded. I think I haven't watched it. It could be terrible, but that contains all the main information I'm going to give you today in a lot more detail. So I want to say you can build apps today in Go for Android. It's hard because the Android build system is complicated, and I really just sort of drop you in it and let you work it out, whatever magic flags you need. But you can do it. And there are two ways you can do it. One way is you can build a library that you can then use from Java. And we have a tool that, given a Go package, generates a Java API for you. And you can just use that directly, and there's no JNI or Swig or any of those things. There's no configuration either, just all your exported types just appear in Java and you can use them. And then you write your program in Java, which is not great, but it could be very useful if you have a large body of code you want to share from your server into your app. And I suspect that is the main way people will be using this, and it's our primary motivation for getting Go onto Android. There's this other way of doing things where you just write your entire app in Go. And what you see on the screen here is an app. That's the whole app. I didn't actually hide anything off the screen because that would be cheating. It's not a very interesting app. What it does is it makes the screen red and draws the frame rate in the corner. But that's what it does. So you can see here we have a main function where we start, and then we call into this app package, which is part of the mobile repository, which does a whole bunch of terrible things you don't want to know about, including setting up a draw function, which gets called 60 times a second. And the draw function is below, and it starts doing some OpenGL stuff. We have a little OpenGL wrapper. It's a very, very simple one that exposes OpenGL ES2, which is the thing you can actually rely on using on Android. Android supports ES3, but only 10% of phones support it, so don't use that. Maybe one day. So what we do is we clear the color, we set it to red. It's an RGBA sort of setup, 0 to 1 floating point. Then we clear the screen, or we set the clear bit, and that flushes the screen, makes it red. And then we use my little debug package to draw the frame rate in the corner, which actually uses free type Go to draw onto a texture and map it onto the screen, all that nonsense that no one ever wants to think about. So it works. And kind of a fun thing, it really works like this. So there you go. So this is a Darwin. I have a sort of a Darwin backend for this as well. So if you compile locally, if you just go get the packages and use it on a Mac, you can pretend it's an Android device, which is kind of fun. So another example, very similar, only now I'm using the event package, which comes in the mobile repository. So this registers another function which handles touch events. And all it does here is when it gets an event, it just prints it. And if we run this little program, now we get a blue screen because I picked a different, I'm very good at OpenGL. Yes. So now if we click and drag around the screen, you see there's a bunch of move events coming up. So I'm emulating touch events with the mouse, which isn't great because you can only use one of them, but it's all there. So that works there. It also works on Linux. We have an X11 backend, so that you can, which draws this whole thing on, so you can kind of use it. That was written by Nigel. That was great. So you could start writing apps in Go, but that's basically all you have to work with. So it's kind of a lot of work. But you could imagine writing a game in Go. It's entirely possible. And you have to sort out the build system, which is not easy. But we could make it easier, and that's the plan. With 1.5, we're going to give you a tool which solves these problems for you. I'm pretty sure we can do this. At least for the native apps, we can do this. For anything where you're trying to build a library to be used by a Java project, we have the problems of trying to interface your Go project with your Java project, which would be possible if there was just one way of doing Java on Android. It turns out there are many. And so this is actually kind of a tricky problem. And so we probably won't have that sorted by 1.5, but we'll at least be able to tell you at least one way you could do it. Similarly, we're going to get more NDK library support. So everything you can see in the Android NDK should be available as a package somehow from Go. Audio is an example of that. We're going to work on the bindings for mapping Go into Java. We're not going to get the complete type system mapped out, but we're going to get enough of it that you can build a practical package very easily. And we're going to have the beginnings of iOS support contributed, which is really quite amazing, which Andrew mentioned earlier. It's kind of tricky because what we're going to have is a Darwin ARM port, which we can build apps with. I have an app on an iPhone that I didn't bring with me because who does demos? The problem with it is starting in the end of February, the App Store will require you to ship an ARM64 binary to ship an app. And we probably will not have Darwin ARM64 ready for 1.5, given that we won't have Linux ARM64 ready. So what I'm suspecting I'm going to do is we're going to have something usable shortly after 1.5, and I will have a forked repository somewhere that you can play with until 1.6 to build apps with. Because I'm very excited about iOS support. And I consider it the most useful part of this project is you can write a library in Go, and you can use it on your Android device, and you can use it on your iOS device and on your server, and you can keep the same piece of code moving around. Similarly, the demo I didn't bring with me is this exact program running on an iPhone, on a locked iPhone. So the nice thing is these packages are designed to hide away the Android iOS differences, of which there are a lot. After that, more native libraries, probably like motion sensors and such for 1.5, given we have a longer freeze period. We're working on a simplified UI for games. So I demoed this a bunch in the Gotham Go talk, and this is basically like a 2D sprite library, animation library. As part of this, a 2D composition layer, which of course is incredibly complex, and it's going to be a lot of work. We have the beginnings of that, so you can take a little sheet of textures, and you can map them arbitrarily onto the screen, and all of this is OpenGL under the hood. And you can use affine transforms to place them, and it's all relatively straightforward Go, and it's all designed to be 2D. And all of that is online and can be played with, and I have a demo game that you can use to try that out. That's it. Fast enough? Questions? Yes.
You mentioned using it in Android as a library by exposing the types. Is
Yes.
there something in the works similarly for iOS?
Yes, so the same tool will be able to generate you Objective-C bindings. And we may even have that ready by 1.5 because HANA is working on it right now. And so I'm kind of excited about that. In fact, that's part of the point is given this piece of Go, I can generate you Java bindings or Objective-C bindings.
It will also be possible then on the desktop for OS X. You just
Yes.
like it and then
Yes,
start the library.
it definitely is possible. We have thought about it. It's just a question of we don't have bandwidth to work on it. There's only so many hours in the day. But I would love someone else to work on it. I'd love to build something that will help them. And so, any other questions? Well, this is set up. Yes. Sorry? It is designed only for helping you debug app design. So it's not meant for building desktop apps. Because it turns out the kind of UI libraries you want for desktop and mobile apps are completely different. And so, but you can totally use it for getting a GL context and drawing on the screen. The touch event library would be very awkward to use for a mouse because you'll want mouse buttons and all those sorts of things. So it's very much not designed for that. But it's all submitted and usable, and I will fix bugs if people find it. But it's meant for mobile development. This is yours. Maybe someone will be able to help pocket these. Put that on. Any other questions?
Thank you. Cool.
All right.
All right.
And show.
That's
Wait.
Penakistoscope.
Yes. I think it's pronounced that way.
Is it Fugaro?
Yeah.
All right, now please welcome Alex Fugaro, who's going to show Penakistoscope in Go, which I have no idea what that is. So.
All right.
Yeah, this
Yeah,
almost half the lining talks that I'm over called Alex.
Yeah. So I think Go slide is too boring, so I made a little change to it. It's like every presentation looks the same, so here's another background for you. So what is this thing I cannot pronounce? It's Penakistoscope, I think. It's a Greek term, and it's a really like an animation device that you rotate, and you get like you get a small movie, and it's like essentially it's this. You have like this kind of circle, and you have different frames for each circle, for each in place for circles. So you, at the end, you should get like a result like this. If you turn it and you look like only for a small frame, so you have the illusion of an animation.
So what we want to do, of course, is to get a cat, which is an animated GIF from the internet, and to make something like this, which is essentially kind of like a phenakistoscope. You can take, you can print this out and cut it with scissors, and you could get like exactly the same kind of effect. So how I did this is I was using I used the image library from the standard library of Go, and I'm going to show you how I did it. Can you see in the back there? So okay. So I'm going to show you some of my awesome math skills here, geometry. So essentially, you just open the file. There's a nice thing which is called GIF decode all, which essentially takes an animated GIF and it divides it into frames. So you can get each image in a slice. So you have a slice with all the images that you need. So what I did is I get the first image and I try to find which one is like the width or the height, which is the biggest, and this is my this is where I'm going to put the image, because what we want is to take each image and rotate it a little bit so that in the end we get like a rotation of each image. So obviously we need to know how big is it going to be the box where we put the rotated image, and we have like we have the slice length. And then obviously the circle length is going to be how many images we have and all these boxes. And because we have a circle length, we can find out the radius, which is this amazing formula. The circle length divided by 2 pi, which gives us the radius. So given the radius, we take a point where we're going to put it inside the generated image. So this is going to be the circle origin. And once we did that, we need to find out the angle of rotation for each image. So essentially, this is what I'm doing here. And then there is an output image. So we have like a new RGBA image, and then you have like a box. It needs a box to generate all its internal structure. And then for each image in our sequence, we calculate the position for the box. So it's like where exactly is this box going to be in our big generated image. So it's going to be one here, and so on across the circle. So this is how it's calculated. And we rotate this image using a library called graphics. It's here. And because in the standard library there is no rotate function, and I don't know how it works, so you have to actually look, but it does. And what it takes an option of an angle. So essentially you rotate it by a given angle. For it does, I think it does like a matrix translation. I don't know what's the formula that it uses for that. And at the end you get a draw. You draw this image, this rotated image, in the correct position. So finally, once we draw each frame in the generated image, you output it to an output.pgn, and you get the round thing with cats or whatever you want to animate. Essentially, the best thing to do it is to take a GIF which has a loop to it. So essentially, the first frame corresponds to the last frame of the image, so you get like a rotation each time, like it tries to begin. So there's a nice Reddit thread which is called Perfect Loops, and there are a lot of animated GIFs with these kinds of different GIFs that have like a continuous animation, continuous looping. So that's it. That's a very simple snippet how you can do your own phenakistoscope, and I'm going to show you how it actually looks like, because I have amazing. So if you look like this, you might see. No, it's not going to work, because actually, if you look here, there is this small thing here. You see the black line. It's actually helping your visual cortex to focus it's like it provides a cue to see the animation. So it's like something which doesn't change in the scene, it fools your brain essentially.
I see.
So this is, but I didn't actually do that. Here, as you can see, there's no cue.
Don't you also usually have a shutter?
Yeah, yeah. You should. I mean, it depends. It depends how fast you animate it. So it's like how fast you rotate the thing. A shadow helps, but you can also look it like this. You can like put. So yeah, I mean, this is. If you wanted to find out more about phenakistal scopes, so zeotropes, whatever scopes there are there, there's a Reddit link, the code if you want to look at it and change it. And one plug about we have a meetup here in Paris about Golang, and next week if you're from Paris, you might want to come in and to see some stuff about the building tools that are used for Go to the build chain, if I'm not mistaken, and another talk which is going to be about client and a server in UNAP, which is also going to be me presenting. So yeah.
It's just that.
Doesn't matter. So that's me. Thank you.
Thank you.
Cool. Thank you. Certainly one of the weirder ones. That's cool. If you just got the.
Yeah. Clip. Thank you.
All right. Where does this go?
All right. And this goes full screen.
Oh, French.
Sure. Oh, okay. I had no idea it was not cloned.
Yeah.
Thank you.
And now Valentin Delaplace is going to talk about Go on App Engine.
Hello everyone, I'm Valentin. I'll try to be quick and loud. Please raise your hand if you know what Google App Engine is. Wow, everyone. Please raise your hand if you don't know what Google App Engine is. One person, okay. I tried to be very, very clear for one person. Thank you. So this is a server instance. App Engine is platform as a service. So you give code and it runs the code, specifically web servers. So HTTP in, HTTP out. And you can write your code either in Go or in Java or in PHP or in Python. And it's a really huge thing that you can write in Go because you can set up and deploy application really fast with that. So one of the main promises of Google App Engine is about provisioning, I mean auto-scaling. If your traffic looks like that and your provisioning is fixed, it's constant like that, you won't be able to handle a spike, and this is bad. So you can add more money, and it's very expensive, but with that you can cover the spike. Until, of course, some kind of popular website talks about your website, and you won't be able to handle the next spike, and that is bad. So the App Engine instances of your application, they are started and killed all the time to respond to your traffic. So the HTTP request that comes from your browser, it goes to one of the instances. It can be any one of the instances. That's why it's very important for the instance to be stateless. And then it fetches some data in the data store or various services that are provided by Google, by the Google infrastructure. Unless, of course, in a certain number of specific cases, your instance is not used at all for the request. For example, if the resource is already in the browser cache, no request at all, and it's very fast. And also, if it's a static file like a JS and CSS, it should be handled, it should be flagged as such in your application, so it will be handled by a CDN-like static file server, and it's also distributed and very fast. And it has no cost for your App Engine instance because it won't be processing it at all. And also, there's a very nice feature called Edge Cache. If you get some previously computed response, HTTP response with the appropriate HTTP response headers for public cache, then it will be cached, and subsequent similar request will have that cached response directly from a CDN-like server. That is very good. And also, if you're doing some kind of uploading or downloading from Google Cloud Storage, you have some kind of direct connection. It's also no load for your instance. And the rest of the time, of course, the HTTP goes to your instance, asks the data store, which is a NoSQL database, for some kind of information, and that takes a few dozens milliseconds, unless the data is already in memcache, which is very, very fast. That's for the global infrastructure of App Engine, the way I draw it. It's, of course, more complicated inside. You have the waterfalls. Usually, when your request takes 600 milliseconds to response, that is not great. We can see it's because of all the RPC calls that are queued. And you can use AppStats in Go and Java and Python to see this waterfall and decide if you can do better. I highly recommend to all of you, if you want to use App Engine, to look at the talk by David Simons, High Performance Apps with Go and App Engine. And I took from this talk these waterfalls. Here you have a bad request because it will take 400 milliseconds to process because of a few RPC calls. So you can cut that in half by deferring some work, like I need to send a confirmation email about that action. Well, maybe I can do that later after the HTTP response, and you should. So it's better. And if you do some batching, I mean, for example, you have for access to the data store. If you can make that only one access to ask the same thing and get the same response, it's much better. Here you have 70 milliseconds. That's a much better responsiveness than the 400 of the beginning. Now the built-in tool traces is available in the Google Developers Console. It's basically the same features as AppStat, but you don't have to install anything, and it works regardless the language you decided to use. I skipped that part about libraries. Those are Google provided libraries to access this and that, and the bottom line is they are the same for all the languages except PHP has less libraries available currently, not because the language sucks, nothing to do with that, only because it's been implemented later on the App Engine. Okay, I got some sample apps. One is a fortune teller. I can show you a live demo. If I get some connectivity, which is not granted. I actually implemented all those 11 implementations just to compare the behavior. So fortune teller in Go is tonight you will get 9 beers. It's a hello world. And if somebody goes to that page, he might see tonight you will get 11 beers. Okay. So a few figures. I set up some load tests. Each load test is 10 minutes. It sends 18,000 requests, and it's an increasing rate. It's a WAMP. and it uses 6 injectors, 2 in Asia, 2 in Europe, and 2 in US. So I get a latency of about 30 milliseconds as measured in the Google Developer Console. That means server side. Like 100 milliseconds measured by my injectors, client side. And there's not a huge difference between the 4 languages. And and what? I don't know. Okay, let's skip that. Another interesting problem will require some CPU work and some RAM. It's memory intensive. I give you a bunch of numbers, a lot of numbers, and the numbers can be great. And the problem is, please find 2 subsets having the same sum. And it's not trivial. And you can look that up on the Google Code Jam from 2012. There is a nice algorithm which chooses random subsets and puts them in the hash map. And when a collision is found, you solve the problem. So a subset is a potato. You have here a red potato and a green potato. The sum for both is 2,743. So this solves this sample problem. All right, so for this CPU and memory intensive task, what does it give? I was quite surprised to see that when I run the problem solver on my laptop, PHP is actually the fastest. Java and Go are about the same, and Python is very, very slow. I could not have figured before I had measured. That's why we have to measure. When I run the same algorithm online on App Engine, we can see that Go response, Java is the fastest, 3 times faster than Go. And PHP and Python are out because they consume too much memory, too much CPU, and so they can't handle the load at all. It's normal because it's quite an intensive task, but it's a shame that the auto-scaling doesn't catch up all that load, so it doesn't respond anymore. Most of the requests end up failing. I guess everybody knows pprof. Who does know what pprof is? A few people, yes, half of the room. Who does not know what pprof is? It's an excellent tool to measure how your program performs. Here I could measure that 35% of the time in my Go program was spent reading and writing hash maps, and 30% of the time was spent generating random numbers. So I could make some improvement, and I got very nice speed ups. I could speed that up by 40 factor. Okay. In the real world, web applications are more like a business application. When you display some nice pictures, you get some data in the database, and you use memcache to cache that. So for this kind of application, as I measured, Go and Java are quite fast. Python is slower by one order of magnitude almost. And I did not have the time to implement the same in PHP because PHP does not have the native library to access the data store. So instead, I would have had to implement some RPC calls, and I did not do it, sorry. And in your company, if you decide to choose Go or PHP or Python, you will have the same dilemma. Will I spend some time to write some RPC calls because the native library is not out yet? So why would you choose Go on App Engine? Because you can, and it's really huge that that was made available by Google. The cold starts are very fast. You can have that problem with Java programs with a lot of libraries. It can take up to 40 seconds or 50 seconds to start, and that's a really big problem. You don't have that with Go programs. You have, of course, the native concurrency, Go routines and channels. And the tooling is very good because you want to develop and test on your local host, you type go app serve, and you want to deploy it online, you type go app deploy, and it works really nice. But of course, you won't get phenomenal speed-ups for your web app because the latency usually isn't dominated by the instance itself or the CPU cost of the instance. Yeah, there are many other factors. For example, in my load test, having an injector in Asia, it was 10 times slower than in the US, just because the instances happen to be in the US. So there are other factors. If you're already very efficient in Java and PHP and Python, I wouldn't recommend the switch. But of course, if you like Go and you want to choose Go, do it because it's a very good idea. And also, you can mix languages with modules. Nothing prevents you from having one module of your app in Go and another one in Java and or PHP. It will nicely interact. Thank you very much. Do you have questions?
I just wanted to point out that there's now a product that's in preview called Managed VMs that is a variation of App Engine that lets you basically specify a Docker file, and inside the Docker container you have an app written in any language that listens on like port 8080, and it does all the App Engine deployment and routing and stuff, and you can take advantage of edge caches, and you can use all the APIs and everything from inside these things, but you're not actually bound to using Go. Of course, there are Go libraries and so on, but yeah, it's kind of like the next level, but it's not. It's still in preview, whatever that means.
As far as I understood it, you have the best of both worlds between Compute Engine and App Engine in the managed VMs. Yeah. And also you have the auto-scaling, I think.
Not yet, but it's coming.
I mean, I used the auto-scaling in preview in Compute Engine and it works. And I thought it was built in on managed VM, but maybe not. Not yet, okay.
But yeah, one of the really nice things about it that I like is that it does use Compute Engine. You can actually SSH into the instances and see what's going on if something weird is happening. And also something else that I forgot. So there you go. Thank you very much.
Andrew, do we have to compare that?
No. But there's just Eleanor McHugh is going to just give one more quick talk before we abandon room. So
yes. Hello.
It's not amplified at all.
Not working at all.
No, it's purely for the recording. That's all.
That's okay. I'll try not to swear.
Pin it somewhere in the middle.
Oops.
Because it's like pointy up. Whatever.
There?
Yep.
Yeah. Okay. No, I don't want you. I don't want anyone.
You need to.
Yeah, I know.
Displays.
It's still fucked up from the last one I did earlier. So, right, here we go.
Under arrangement.
Oh.
There's
yes,
mirror.
I'll remember that. And I guess scale it.
Actually, yeah, it depends.
Because there's going to be code.
It works.
Yeah, okay. And
wherever it is.
Wherever it is, yeah.
Do you have multiple profiles?
No, I don't normally.
There it is.
Right, here we are. So, yes.
All right.
So this is possibly going to be a bit of an incoherent ramble because this is about code that I spent the last couple of days writing for a talk my colleague Romek and I gave over in the security room earlier about hybrid cryptography. And most of our research work over the years we've tended to do in Ruby because it's very, very quick to build up crypto systems using Ruby. It's got OpenSSL bindings. And, but of course, I'm really much more known for my Go these days now and for my Ruby, which is a bit weird. So it sort of occurred to us it would be quite nice to knock up something, you know, that showed crypto in a web context in Go. So I did. And yeah, at 5 o'clock this morning, after I'd been out last night karaokeing with some people, it occurred to me it would be the perfect time to learn how the cipher.stream stuff works. So this stuff uses it with one small bug. So this is me. This is my GitHub. Web crypto demo is actually the stuff that I'm going to talk about, and I will actually figure out my bug, and then the code will just sit there, and you'll be able to see how to do REST-based web services that happen to just do hybrid crypto. And because I like to plug things because it's part of how I earn my living, I'm also writing this nutty little book, which is supposed to be about Go, but people have said the first chapter is really a cryptography primer because it's 60 pages of hello world and crypto, you know, down to RSA over TLS, over UDP and things like that. I mean, basically, it teaches you that Go is a really good language to muck about with crypto in, and networks. So, so that's the plug. Yeah, code. Let's get rid of that. Don't need that. And try and make some of this readable. I'm not really sure which bit I want to talk about because I have had like an hour and a half sleep since Friday, which may not have been such a good idea. So, I mean, firstly, Go is a really nice language to write web services in, microservices. Most of, I mean, I normally, if I've done web stuff in the past, I've normally used something in Ruby like Sinatra. And in fact, this work is sort of a very distant outgrowth from a system I wrote for HSBC a couple of years ago, which is a two-factor encrypted database with a Sinatra front end for an ID system. And Sinatra gives you very, very simple sort of DSL that allows you to just basically have a couple of methods that get called and suddenly you've got this web app. And I was expecting, because this is the first time I've ever bothered to figure this out in Go. I've never bothered writing web stuff before, and I was expecting it to be somewhat more painful, and I discovered this was quicker to build in than when I was building with Sinatra in Ruby, and that's come as a huge shock. However, I have used one small cheat. I'm not actually using the standard library's HTTP standard route, I'm using that, which is fecking fast, gives me Rails-style URIs, and whilst I know there are people who think that they want to have regex matches in here, they're wrong. They want variables that they then check against regexes, because this is how URIs actually are supposed to work according to RFCs. We're kind of hot on that because we do an awful lot of work with URIs. Basically, here I've got a little application that allows me to register a user, and then a user is able to register a key they want to use, and then they're able to store a file. Oops, are we in the TLS version or are we in the actual hybrid crypto one? Hold on a sec. I could be in a context buggered state. Okay. I shouldn't have said that because this is being recorded, but I have an awful habit of swearing when I'm tired. So please forgive me. Yeah, this is the one that's actually interesting. So in this scheme, basically, we ask our server with a simple HTTP GET, could you please give me a public key? Now, you could do this with TLS. TLS is basically giving you hybrid crypto for free, but it's giving you no control over your hybrid crypto. Because you do this public-private handshake, then you tell each other what algorithms you're using, and then you swap an AES key normally. And it's the AES key that's actually used for most of the on-the-wire crypto. But it's all in a single tunnel. You can't decouple it. A lot of the stuff we do, it's actually quite important to be able to decouple. For reasons I'm not going to go into today, it's patent pending. Which is awful. I've got patents pending, and I hate patents. So I'm going to run a bit of code to prove that there's some code that runs, assuming I can get my terminal up to the right kind of, let's see. So I've got this little server, and nothing exciting is going to happen there unless it crashes. And over here, I've basically got this little conversation that's going on in the client I wrote. Oops, stop doing that. That's the wrong client, so that's the one I want. Right, so we basically have this little conversation. The client asks for the public key. It registers a user. This actually means that the server creates a random user ID and gives it back to me. And that's cryptographically secure, random, big number stuff, which is great, because security through obscurity is the best way to go. And then I'm going to generate an AES key, and I'm going to send that back to the server. And then we're going to communicate from then on using that AES key whenever we send any large binary stuff. And that will be the bit where I show you the bug, because there's something I can't figure out how to do yet. So in this conversation, we go through, we've got a user status we can get back, and that's actually sent encrypted on the wire. So that's quite important, because otherwise this doesn't look at all good to know that. So here we go. We run the client in more. Right, so we've asked the server for some information about itself. That's just to prove we've got a server. And we've gone off and we've created some stuff, post requests, dull. And then that proves that we've created some stuff. And then we come down here. You'll notice, a touch bigger. It's these damn contact lenses. Everything looks massive to me. So now it's leaping out the page. Right, as you can see, this is our user identifier. This is a standard URI parameter. That's because this is actually a resource. This is how it should actually be done. If you're going to do REST, this is a resource. If you want to access a user, that is the user. You want to do gets and puts and posts against that. And if you're going to use a post, it's because you want the server to do some back-end processing. And if you do a put, it's because you've actually got a resource to replace the existing one with. This stuff is dead easy to do. And pretty much every RESTful library on the planet gets it wrong. It just doesn't follow any of the RFCs properly. So here we're getting back to user status. As I say, that's actually encrypted on the wire. We've decrypted it as we've received it with the symmetric key that we gave to the server, which is not such a great trick, really, but I mean, it can be used for all kinds of other exciting things.
You got 2 minutes.
OK, 2 minutes, that's fine. So there's lots of stuff in here that's actually interesting in the code base, but there's one really fascinating thing. And as I say, this was the idea that struck me at 5 o'clock this morning and led to a refactor that made us think we wouldn't have any working code at all at 1 o'clock at lunchtime. And that's the fact that we've got these cipher streams. What it basically means is we can take anything that's a writer and we can wrap it up in a crypto cipher. And just by writing to it, we can automatically have the content encrypted for us. So, because this is one of the lovely things about the standard library, is the fact that so much of it is written in terms of readers and writers. So it's literally just like having a crypto middleware that you plug in. There's one caveat on this. There's one thing I can't figure out. The most standard way in which when we are doing encrypted communications, normally we have a thing called an initialization vector, without which we can't actually do our crypto. This is something you can send around, totally public, doesn't matter, it doesn't compromise your key. But normally, we stick this at the front of the message before we send the message. This is the easiest way to transport it. The way in which the cipher library seems to work, it seems to completely chuck away anything that's already gone down the writer, because I'm using HTTP response writers. I'm basically just dropping these in and automatically encrypting them, which is amazingly good fun. But it seems to chuck my 16 bytes of IV away, and I can't figure out how to get past this. So until I can get past this, what actually happens is I stick my file up, and my file gets transferred perfectly fine, encrypted on the wire, gets stored differently. I ask for it back, it gets sent back, encrypted on the wire, and then garbage comes out because I haven't got the IV. So apart from that, I would say that cipher streams are fantastic. They're so fantastic, I'm almost tempted to port them to Ruby, which doesn't have the concept at present. Because more legacy with OpenSSL is really what my life needs. But anyway, this code, it's on GitHub. I will be fixing the bug as soon as I can figure out how to fix it. It basically shows you how to do a RESTful storage service where you are in charge of your crypto, where you can change your keys on the fly. And in fact, I called these things users, but really, they're nodes. Every identifier is a node. The node space that I picked is something like, I think it's something like 16 bytes or something is the node space. So you don't really have to worry about getting rid of things. So Anyway, I invite everybody to come and have a play, and also to buy my book. It's only $6. But enough of you buy it, I'll write chapter 2, which will be about this stuff.
And thank you guys,
And now I can go
everyone,
and
for
sleep.
coming. And I hope you had a good day here and so on. And see you again next year, maybe at one of the conferences I mentioned earlier.